Okay, so I think we are live right now. So I'm Stefan from Swarm City with Eduardo here from Givit. And we'll try to discuss and do the first meeting about the IPFS consortium right now, which should take maximum 1 hour. On the GitHub, I posted the link if you want to participate in the live stream too. So if you want to join in, feel free. So without further ado, let's dive into the agenda maybe. We have Matt saying, I don't see video. No, I'm my video is turned off right now. So to make sure that we have enough bandwidth to hear everything. So I think that'll work. So for the voting and governance, so I don't know, Eduardo, so maybe you have, because I saw you had made a pull request to create or to integrate stuff, but I think you had some remarks on that I saw today. Maybe you can elaborate a little bit on that, what you exactly done, and what in your opinion should be changed still?
Yes, the fact in this part is shareable contracts have problems. I put a comment about that. Shareable don't have add owner or remove owner, so the problem here is that after its creation, it's impossible to add new members. So I researched about this and I found another contract from wallet.sol. It's in the comment, and this contract have these methods. So I think it's more useful for this case. So my pull request, I think, is need to close use this new contract.
Hello, this is Thomas from Oracleize. I could finally join. Sorry for being late.
Hello, Thomas. Welcome to the stream. No, happy to have you here.
Hello, thank you.
We were just looking into like the first issue on the agenda is to see how we could like create some sort of a very simple governance model into the IPFS consortium contract. So our initial idea was to integrate the multi-sig functionality. So Eduardo has been doing some work on that, and it was just explaining what he had done and what he was doing. So maybe I'll let him finish that, and then maybe I'll take one step back and just explain in a few short words what the goal of the IPFS consortium is. So maybe you can also pitch in what you're interested in, Thomas, and where do you want to see it evolve into? So maybe I'll give the word back to Eduardo first.
Okay.
Yes, fantastic. Then maybe after Eduardo, I can briefly spend a couple of minutes to explain you guys what we have done at Oracleize on the IPFS Persistence Consortium, as we have started something very similar based on the work of Piper Merriam. I don't know if you are aware of his work. He published something over 1 year ago.
Yes, we looked at it before we started the IPFS consortium.
Okay.
Yeah, so we were, at least I am pretty aware about what's been done on that. Okay.
Okay, perfect. So we can discuss later.
Eduardo, back to you.
Okay, the problem with shareable contract is that this contract don't have methods to add members or remove members. So after the creation of the contract, you don't have the possibility to add new members. So I think it's a problem. I made a research about that and found another contract with these methods.
Yeah.
I put a comment into the issue.
Yeah. Yeah, so I think the solution that you propose would be to really integrate the real multi-sig methods, or just pull them out of an existing contract and reuse them here. So would that enable us to actually do that?
Yes, I think it's the solution. I have a doubt about the users. I think we need two types or two groups of user, or only one is the question here. I mean, we need members and admins, or only one of them?
Yeah, so maybe let me talk a little bit about like the broad idea about the IPFS consortium, so that might also answer your question at the same time. So the reason we wanted to start the IPFS consortium is for our project in Swarm City, we needed, or we are using IPFS already to persist some data of our users. So we have a DApp running where people can actually do business with each other, so give service to each other and pay in cryptocurrency. Now, to create identities, for example, we are storing, for example, avatar images of people, and therefore we are using IPFS to do so. So we are hosting, I think 1 or 2 nodes, which are an IPFS daemon. So the problem that we're facing is a problem of persistence of the data. So we want to make sure that even if our service would go offline, that we were sure that all the data of our system was still intact, because it's not only avatar images, it's also intermediate state of deals, for example, which we store as JSON payloads, and we save them on our IPFS nodes. So first of all, if we only run our own IPFS servers, that's not really decentralized. But on the other hand, if that was the main problem, basically. So that we don't want to rely on our service only to persist the data. So therefore, we figured that there were other projects, a lot of other projects, certainly in the Ethereum ecosystem, that we saw were also using IPFS. So we tried to reach out and also find a way how we could persist that data. So the idea of the IPFS consortium basically is that we can share resources with other projects. So other projects are also hosting their own IPFS nodes, and they even might have, just like in our community, have community members that are willing also to support the network by running an IPFS node and to host data specifically for their project. So there was the idea was born of creating a consortium between different projects. And the way that we have tried to implement it right now is that we use a smart contract, which contains a list of members. So that means that all the members are sort of trusted parties in this consortium. So the goal is not immediately that a decentralized app would be able to post data to the IPFS consortium, but actually the members would be able to send each other IPFS hashes that the other community or the consortium members would pledge to pin in their local IPFS repository. So that means that we are supporting other projects and other projects are supporting us in persisting data. Another thing is that we don't require consortium members to actually provide, let's say, an IPFS gateway. That's not necessary. The only thing is that we need to have like the guarantee or the to create a deal with the other projects that we just host each other's data to make sure that over the IPFS network the data can always be retrieved back. So I think that sort of sums up what we wanted to do. I think the difference between the project that already existed so the existing IPFS consortium is that we are actually using the smart contracts, so the Ethereum network, to build on top of. And so our solution consists of 2 different parts. So one is the IPFS proxy contract, which basically has 2 functions. So the first function is to add and remove members. So we can have a management of the members. Just screen sharing here. So normally you're able to see this. So we have a remove member and an add member. It's somewhere else over here. Can't find it immediately. Okay, so and if you are a member of the consortium, so which is simply listed in a local array in the contract, then you're allowed to add or delete IPFS hashes. So, and how does that work? So it can be done in 2 different. It can be done in a number of ways. So the most immediate way is that you can just call the function add hash or remove hash. if you add a hash, you can add your IPFS hash and set a time to live. So that means that you want the other parties in the consortium to host or to keep this IPFS hash for this number of seconds, basically, to pin this in their repository. So you can also have sort of an indication of how long that should be persisted. You can remove a hash if you say we don't need it anymore. So that's the first method. So that's if you would call it from an external source. So if you have like an own script or a backend script or whatever, which wants to add an IPFS hash, you can do it like this. So that's the first way. And the second way would be if you have another smart contract. So if you're running an own dApp, for example, and you have a smart contract that wants to add IPFS hashes to the consortium. Therefore, we have implemented some events. They are here in another file. Let me quickly show you that. Now it's called IPFS events. So it just has two events like hash added and hash removed. And if you call, so if you inherit from IPFS events.sol, so if you implement it in your own contract, then you can actually use that to add IPFS hashes from your own contract consortium. So the way this works is just like here, the IPFS proxy, for example, it also implements IPFS events. And when you are a member, so if you're part of the IPFS consortium, you can actually add contracts. So you can add or remove contract addresses. What this does is that the scripts, which I'll go over after, will actually listen to those contracts and listen to events of the type hash added or hash removed. So that means that you can also add new hashes on chain, so from one smart contract to the IPFS consortium. So these are currently the two ways you can add and remove IPFS hashes. And then let me quickly show you how the consortium itself would work. So each consortium member should run this script, which is called proxy listener. We've proposed it here in a Docker container, so you can just create a Docker container and spin it up. So this is a proxy listener. So basically what this script does, and I'm not going to go over all the details, but it's actually pretty simple. It will just listen to all these events, like contract added, member added, and then banned will maybe go a little bit further after that. But if you add the contract, it will register that contract and listen to the events hash added or hash removed. If it adds a hash, then it will pin that IPFS hash locally into your IPFS host, which is running normally on the same machine. Now, there are still some things to be done because, for example, we are currently not checking the file size of the hash to compare it to a quotum. So the idea of the quotum is that each member, and it can also be set into the smart contract, but it's one quotum for the whole, let's say for each member. So it's all the same. So each member has the same amount of quotum. I think it's currently set, but we can change it later on to 10 gigabytes. So that means that each consortium member would get 10 gigabytes of data. And the script could actually monitor this quotum. So each IPFS hash that it would pin in its local IPFS node. So the sum of all of that would not, we should not exceed 10 gigabytes. If there would be people that abuse the system, there's a method, but that should also have like the multi-signature thing probably later on, where people can actually ban a member. So if a number of members actually signal that a certain member is going over his quotum, then a member can be banned and it will permanently, it will temporarily be removed from the list. It can be added later on, but then you won't like pin any further IPFS data from that member itself. So I think these are like the broad lines of how the consortium would work right now. There's, for example, there are no incentives given for storing or hosting this system, because the idea is that this is just a list of projects who try to help each other in persisting each other's data. So yeah, that's basically the current scope. So I don't know, Thomas, how that fits your use case, or maybe you want to comment on the way we are doing things right now.
Yeah, thank you for recapping the work that you guys have been doing on GitHub. I've been reading it before joining the call. Actually, I've been taking some notes around your points, but I will start by doing a very short introduction so that you understand what is our use case and why we need it.
Mm-hmm.
So on our side, Oracleize is being used by several contracts, mostly on Ethereum, to fetch data feeds and other data from web APIs in a provably honest way. So along with the data, we deliver also authenticity proofs. Those authenticity proofs are a collection of signatures and other data you need to verify that Oracleize is behaving honestly and not tampering with the data. So these authenticity proofs needs to be stored because basically our clients need to be able to verify them at any time, also for the past. This is very important because if you have all the authenticity proofs, you can verify at any time that Oracleize didn't tamper with the data for its whole existence.
Mm-hmm.
So what we do in, I would say 80% at the moment of queries is sending on-chain just the hash, the multi-hash, the IPFS multi-hash of the authenticity proof, and we distribute over our IPFS node the content. So basically, anybody can try to fetch data over IPFS, and they should be able to fetch it if our nodes are available. This is not a guarantee that the data will be persistent, though. This is why we have set up this IPFS persistent consortium around 1 year ago, 1.5 years, based on the code of Piper Merriam. So the idea is that we pin there and we list there all the content we want people to keep a copy of, and basically it's them choosing if they want to keep it or not, depending on their needs. So, for example, our clients might say, okay, so it's important for me to keep a copy on IPFS of a set of files because we want at any time to show to our customers that the data was authentic. So at the moment, we have around 20 gigabytes, so we will be already over the limit. Because as we speak, we are sending on the mainnet only between 2,000 and 5,000 queries per day. So we have quite a lot of content to pin. I have some questions around the architecture that you guys had in mind, which is around the choice of using smart contracts for the governance and for adding the IPFS. So on the governance, it was just, well, it's not really anything bad. I'm just trying to think out loud and see why do you guys think we need a smart contract for the governance model, since the smart contract cannot verify if the members are behaving honestly or not. So the smart contract cannot verify if a given IPFS node is really keeping a copy of the data or not. So this is based on a vote, as if I understood correctly. So we basically promise to ban a member if the majority or something like that notices that a member doesn't have a copy, or how would it work?
Yeah, so currently the governance model assumes that we sort of know the different participants in the consortium. So that means that all the public keys that are listed in the contracts are assumed to be like the public keys of the, let's say the people who are actively participating in the IPFS consortium. So we assume that they will behave correctly. Now,
so basically the parties involved are not pseudonymous. They are known parties, and they trust each other. So why do we need a smart contract?
So I think the smart contracts right now mostly serves as a convenient way to propagate and to basically broadcast all that data. So that's one thing. A second thing that we also saw and actually needed in our application was that we needed some way for another smart contract to actually start pinning data on IPFS or sort of broadcast data on for IPFS.
Okay, so I agree with this need. I think this is something very useful to have like smart contracts that they should somehow claim that the owner is a member of the consortium. But let's say that we have a list of smart contracts for each member. Then we can say that the events coming from those contracts might contain references for IPFS objects to pin. Yes. This is good. But what I don't like, and this was my second point on smart contracts, is the missing possibility for members to pin IPFS objects without Ethereum transactions, because this is not really scalable much on one side, in the sense that if we need one transaction every time we need to pin an IPFS object, it might become quite expensive and it could just blow up the blockchain for some use cases. Yeah. And also because and this was another question.
Maybe can I quickly respond to that, Thomas? Because
yeah, please. Yes.
Because but it's not. It hasn't made it to the GitHub yet, I believe. Maybe I should check. Yeah, so it's already there actually. So we have like a Whisper extension. So our idea was that you could also use Whisper. You know the Whisper probably.
Yeah, of course.
Okay.
Yes.
So you could also use Whisper. So we could set up like one topic or like a list of several topics, depending on how we would use it, to actually put in a request to add or remove a hash. So with more or less the identical signature like the function has right now. So just with a IPFS hash and a time to live. And the thing we could do is that we actually sign this message, this Whisper message, with the private key of the same IPFS consortium member. So you would also be able to broadcast an addition or removal of a hash over Whisper, and I think that way you could doing transactions or having to do transactions for each and every IPFS hash. So that would be possibly a solution for that.
This is very useful. Yeah, this is a possible solution. I like that, and I can see possible use cases also for using Whisper. But still, I think that there might be a need also for another method to push IPFS multi-hashes that we want to pin. And I think that the original method that was used by Piper Merriam was quite clever, because it was based on a manifest file on IPFS itself.
Yeah.
So it means that this could be another way. So we could have like on-chain smart contract sending the event, transaction claiming to the, what is it, the IPFS proxy, I think, contract, which hash we want to add. Whisper, and we could also have this other way maybe, because this is very generic. And this comes down to another point I wanted you to discuss with me, because I think it's quite relevant, which is, do we want this IPFS consortium to stay within the boundaries of the Ethereum ecosystem only, or why would we do that? I mean, this is a need probably which is more general, right?
Yeah.
And we know that Swarm will give some guarantees of persistency of data at some point with the incentive mechanism. And we know that IPFS will do it as well with Filecoin. So we cannot compete. It's a different goal. It's a short-term goal, because our projects, they all need it, right?
Yeah.
So I like it, because it's a very quick way to solve a problem that we have today, and that we know it will be solved by other projects at some point, but we need it now.
Yeah.
So why don't we keep it more generic? This is also why I had some doubts on the Ethereum contract.
Well, yeah, just to give some quick replies or ideas on that. So I think first of all, I agree that it shouldn't necessarily be limited to Ethereum projects only. My only concern was that maybe if you use one like gigantic IPFS consortium where everybody would pin each other's data, it might be in the end like the let's say the goal, let's say the lower barrier for coming into the IPFS consortium might be too high for some people.
Okay.
Meaning that if you already have like 30 projects and they all want to have like 10 gigabytes, or like in your use case 20 gigabytes, so let's say 20 gigabytes, it means you have to provide 600 gigabytes of data before you can actually join the IPFS consortium. So I don't know if you have to have one big consortium, or maybe you could have different groups of consortia.
Yeah, I was thinking that maybe I don't know how complicated this is, because I didn't think of it from a technical perspective. I don't have yet precise ideas or of how I would write it down in code. But I was thinking that maybe we could have some contexts, name, some tags or something, where people can say, for example, this data is for, I don't know, a Ethereum ecosystem. Or this other data is for, I don't know, something else. And then people maybe could choose which tag to follow. And the problem is that it becomes more complicated. And how do we balance people using different, pinning different sizes? For example, let's say we want to pin, as Oracla is 200 gigabytes. And you guys want to pin 2 gigabytes. So what do we do? Do we just say that Oraclize is out because they want to pin too much data? Or do we say that Oraclize has to pay something to the rest of the members for the persistency as a penalty, maybe? Or do you have any ideas?
My initial reaction would be, let's keep it simple and just consider it. If you want to keep it very, very simple, I would even say just start with cooperation between different Ethereum projects and don't impose any like mutual payments or anything. Just say, okay, we all have one limit that we all adhere to. So it might be that we as, like say, Swarm City only need 1 gigabyte and you guys need like 30 gigabytes. So that would mean that we set the limit to 30 or maybe even 40 gigabytes. And we just say, okay, anybody can put in 40 gigabytes if they want. But if we just use 1 gigabyte, okay, then so be it. I mean, it's just a solution to get this thing started, because I think the more complex we'll make it, I think it will be maybe too similar, like you say, with upcoming systems like Swarm or just like other more advanced systems that are now being developed. So, like you said, it's
I agree in keeping it simple.
To have a solution right now.
Yeah, I agree in keeping it simple. So this is one way. But still, if we want to keep it simple, why do we enforce the need to keep an Ethereum node running? Just to synchronize the members list. I mean, members will probably not join and leave on a daily basis. So it might be just maybe enough to have a mailing list or something to discuss, and then to update a members file from time to time or something like that.
Yeah, well, the idea was, since the technology is already there, to sort of have a simple governance model on how to add or remove members. I think that was the idea, and certainly using the smart contract as a way of just managing a sort of a whitelist of public keys that actually can manipulate the list of pinned IPFS hashes. I think that would be useful. Certainly, if other people like us, for example, want to pin content from other smart contracts that we'll deploy, because I think that's more or less the only way to have like a centralized list of centralized in the sense it's a smart contract. So it's decentralized, but it's a centralized list in one contract. to have just to know who you should listen to and whose requests of IPFS hashes you should simply ignore.
Okay. Yeah, I think I agree with the current design, as long as we also add the functionality I was mentioning to pin to add to the IPFS pin list. Also something that doesn't need Whisper or Ethereum transactions, because this would be convenient for use cases. Also for us, for Oracleize, it would actually be more convenient. We have some clients that don't even use the system on Ethereum, but most of them do, and I think it will be beneficial.
Yeah,
we can do the pull request ourselves. So.
Yeah, that would be great. I think also maybe to answer on your idea of having lists of IPFS. So I looked into the implementation about how the other IPFS persistence consortium did it in the past or now doing it. We could also add, and I think it should be like another method that says, okay, this hash contains a list of other hashes. So we could exactly use the same format that they use in the IPFS persistence consortium.
Yeah, right. I agree.
To list up all the hashes, but the same, instead of add hash, something like add hash list or something. And then the script would just read that IPFS hash, resolve it, see what all other hashes are in it, and then you have exactly the same functionality as before, I think.
Yeah, I agree. I mean, each member could provide, the public key, the Ethereum address, but also the IPFS ID, which is pretty much the same. I mean, as a concept. And then, when you have the IPFS node ID, each member that is willing to do that could just publish an updated list of contents they would like to be listed. So this will be similar to what the IPFS Persistence Consortium, the old version, did. And basically, this new project will be we would have extended functionalities.
Yeah. Okay, no, so that sounds great. So right now, we are sort of talking mostly to the Givit project, because they already said they want to participate in this. So if you guys also would want to join in, or at least take a look at the code and maybe write a pull request, that we have something that it's also possible to have it from outside of the Ethereum ecosystem. So I think that would be great, and I think the invitation is still open to other projects if they want to take a look at it, or even join the consortium. So I think it's we're all open to that. For the rest, I think during the next week somewhere, we'll try to, at least on our side, set up our first node. So if we have the next version of the smart contract, the idea is to deploy it on the live net, and just to try it out, we'll set up one node already. I imagine that that Eduardo or the Givit team will also try to set up another node, so that we already have two nodes running, and maybe we can just see from there, see how it goes.
Yeah, we would like to open to start our node as well. We already have one, so
yeah, it would be great. And so we'll just like add a fresh node, so it will be new. It will be running the IPFS proxy scripts like we have it right now, or maybe with like some of the improvements we'll have in the near future, maybe the middle of next week, the upcoming week. And that would just notify everybody on the GitHub. So Thomas, maybe you want to keep an eye on that. So yeah.
Will you guys be in Cancun for that country?
Yeah, we'll be there. So I will be, and most of the Swarm City team will be there. We'll also have one big house there in the vicinity of Cancun. So maybe we'll see you there.
Yeah, definitely.
Yeah, that would be great. And I think the Givit team is also coming there. So I don't know, Eduard, are you also joining?
No, I'm not be there, but other teams remember.
Okay, too bad.
Next time.
Yeah, next time. DEFCON 4. Okay, great. So I think maybe we can wrap it up here, unless Thomas or Eduardo, do you have anything else to comment on?
I'm checking the notes. I think I've pretty much discussed everything I had in the list. Yeah. Well, maybe something else if we want to spend 1 minute. Do we want to, how would we increase the limit if we do it at any time? Do you foresee the limit to be dynamic at some point? Do we keep it static for simplicity? Or if maybe the majority of people votes to increase it, then we can increase or decrease it?
Yeah, I mean, you can always choose to sort of leave the IPFS consortium. I think the only rationale now to have a limit is that you can actually provide or easily provide your node, because you can see how many members there are and you can see what the upper limit for each member is. So if you multiply those two, you know what you should provision on your nodes to be able to be like a full participating nodes. But it's not really to enforce anybody or to exclude someone. It's just a sort of convenience to have some idea of limits.
So does it mean that every time a new member wants to join, there needs to be an internal vote so that people say, yep, I would have 10 gigabytes for them? Or because the onboarding needs basically more space for all the members, right? So do we vote every time somebody wants to join?
At this moment, that hasn't really been decided yet. I think with the idea that right now it's a sort of a small group of people who actually know each other, so we can discuss it. It's not like we need a like an anonymous sort of DAO working right now, because it's just some participation between different projects, and the Ethereum layer just makes it convenient for everybody to monitor the activity and to update their own nodes, and to get that guarantee that other members will also persist your data. I think that's the current scope. So if you have suggestions on that, feel free to comment on them in the GitHub, of course. But I don't think that's the scope of the IPFS consortium at this stage. All right, so then we'll wrap it up here, I guess. So yeah, maybe we'll, like I said, we'll post the updates when we have the nodes ready and running. We'll post it there, and then probably you'll see some activity on the side of the smart contract yet. And if you have like contributions to do, feel free to do so, and then we'll see each other on the GitHub, I guess.
Okay, perfect. Thank you very much for organizing the call.
Okay, very nice for you to join, Thomas, too. And then Edward, we'll hear each other later on.
Thank you, guys.
Okay.
Thank you. Bye-bye. Have a nice weekend, guys. Bye-bye.
Same to you.